In this section, we're going to review what we mean by a pure monopoly. So we've gone through perfect competition. And just to remind you that a monopoly, as the word suggests, mono meaning one, there's only one producer, a sole producer, one supplier of the good with no close substitutes for it. So you can think of telecom, telecommunications industry being a monopoly till 2006. Then you start to get cellular network operators, etc., moving into that market. You can think of Eskom, and electricity generation in South Africa. And you can also think of some of the potential problems surrounding monopolies and monopolistic power. And we'll talk about that. How do we measure market power? We're going to talk about that later in the section. So with a monopoly, entry to the industry is completely blocked. There are substantial, huge barriers to entry. They might be because of legislation. There's only one license issued to operate. And those could also be issued for good reason. Maybe certain safety, health standards, and etc. However, one has to look at the consequences and what one could do to perhaps create further competition within that industry. So a monopolist has more control over the price, but it still must consider demand curve it faces. It still faces a downward sloping market demand curve. And I think this is an important point. I mean, I've often read essays written by students where they say a monopoly can charge any price it likes. Yes, a monopoly can set the price, unlike in perfect competition where the firm is a price taker. In a monopoly, they are a price maker. They can set the price, but they're still subject to the demand curve. If the price is higher, they're going to sell less, etc. So they can't just charge any single price they like. If it's unrealistically high, you might find consumption zero. So, depending again also on what good it is. But you need to also consider that the marginal revenue curve is different from your demand curve. Okay, so we find here that price is not also equal to marginal revenue, as was the case with perfect competition. We find that we get a downward sloping demand curve, and if the demand curve is downward sloping and linear, straight line, your marginal revenue curve will also be a straight line that starts at the very same point on the price axis as the demand curve, but it's got twice the slope of the demand curve. And it actually hits the quantity axis at half the quantity of the demand curve. We're going to see an example now. So once again, like as I said, for all firms, price is equal to average revenue, and the various points that you draw along your demand curve, if I draw one here, okay, so if we've got a demand curve for a monopolist, okay, it's downward sloping, right? And the higher the price, the less it sells. But we find that its marginal revenue curve intersects your price axis at the same point, but it cuts the quantity axis at half the quantity of that which the demand curve intersects. This is the demand curve, this is the marginal revenue curve. Okay. And so, in other words, your marginal revenue curve lies halfway between the demand curve and your price axis here. So that's what it looks like. Okay. And your various points along the demand curve gives you the various prices that can be charged and the average revenue associated with those. Remember that price is equal to average revenue by definition for all firms. Okay, so here we've got, okay, so we'll get a better diagram, the one from the textbook here, to illustrate the monopolist demand curve that's downward sloping. If you're given what we call an inverse demand curve, an expression for it, say here it's equal, P is equal to 24 minus Q. Okay, it's as if there's a 1 there. We don't write that coefficient, but we assume there's a 1 there. You can then find the expression for your marginal revenue curve. It's going to have the same vertical intercept. It's going to be 24.2. In other words, remember how you get your vertical intercept. You put Q equal to 0. So this term on the right-hand side falls away. So P is equal to 24. That's how. So when Q is 0, you find P is equal to 24. That's your vertical intercept for your demand curve. And your marginal revenue curve is exactly the same. It's got the same vertical intercept. If Q was 0, MR would also be equal to 24. But it has twice the slope of the demand curve. Okay? If Q is equal, if the coefficient here is next to Q is equal to 1, if it's got twice the slope, it's going to be equal to 2. So you can easily find the expression for the marginal revenue curve if you have an expression for the demand curve. And we call this an inverse demand curve, where we make P the subject of the formula. The reason for that is, if you can recall, that the first person who drew this demand curve drew it kind of the opposite way around from how we typically represent things in science. We usually put the independent variable on the horizontal axis, and remember, price is the independent variable, and the quantity depends on the price, so we usually put the dependent variable on the vertical axis. So because it's the other way around, we typically express it in terms of what we call an inverse demand curve by this expression here, where we make P the subject of the formula. So if Q is the subject of the formula, just rearrange it in terms of P, and from there you can easily find your MR functions. Very simple to do. It's always the same, same vertical intercept, same as this. They intersect the price axis at that same point, but your MR curve has twice the slope. You can then draw in a marginal cost curve, upward sloping, and you find wherever your MR equals MC, remember that's your amnesia rule, the profit maximizing output for all firms, you can then find, okay, that's where your monopolist is going to produce, say. You can find the monopolist's profit maximizing level of output, QM. However, it will have to go up to the demand curve at that profit maximizing level of output, go up to the demand curve and read off there to see what price it's going to charge. Okay, we'll see that over the page. Just going back to that, and you'll see that the price it charges here, given by this, so the price the monopolist charges, is going to be greater than the marginal revenue and marginal cost, basically, at that level. So the price is going to be up here. Your marginal revenue and your marginal cost is given as 12. So price is above marginal cost. So straight away you can see that it's actually not as efficient as perfect competition. There's no allocative efficiency. Where price was equal to marginal cost, the price is now greater than the marginal cost to society of producing it. Remember, too, that price elasticity of demand is the percentage change in quantity demanded. I usually express it like that. That's your price elasticity is equal to the percentage change, delta, that's a triangle, in the quantity demanded, okay, call this QD, over the percentage change, I'll try and do the triangle neater, in the price. Okay, and we know that because of the law of demand, we usually get an inverse relationship here, that if the price rises, we find the quantity demanded falls, and vice versa. The price falls, the quantity demanded rises. There's an inverse relationship. But when we look at elasticity, we're not particularly interested in the sign. We know it's negative. We're interested in how much does this top thing change? How much does this quantity demand change relatively or relative to the change in the price, the percentage change in price? So if the price, for example, goes up by 1%, we're just interested in what is the relative change in the quantity demanded. Is it something smaller, like 0.5%, so it changes by less than the change in price? And if it's like that, we get a value of 0.5 over 1, we get a value of 0.5, we'd say that that's a very price inelastic demand. That as the price changes, the quantity demanded doesn't change by very much. And we find that for things like cigarettes, etc., that demand is very price inelastic. Consumers are not very sensitive to the price. Put the price up and people continue to smoke because they're addictive, etc. So you've got much greater scope to increase the price with the product with the price and elastic demand. As opposed to, if you get say there's a 1% change in the price and the quantity demanded rises, let's just say the price rises again by 1%, your quantity demand is going to fall. But let's say this time it falls by much more than that. It falls by 5%. So relatively speaking, that's an elastic change. It's a much greater change. It's like exerting a certain amount of pressure on a piece of elastic and seeing how much it changes. If your substance is very elastic, it's going to change by a lot. If it's not, it changes by a little bit. So for an elastic response, you get a big fall off in the quantity demanded. So you wouldn't advise, therefore, putting the price up. Okay. So we know this has got a negative sign. Okay. So what's this got to do with what we're talking about? We see that where will a monopolist maximize profit? Again, the golden rule there, where MR is equal to MC. And the monopolist will actually never operate in the inelastic portion of its demand curve. Let's have a look at a diagram to see why. Okay, so there's your demand curve, and we know you did this in first year, that your elasticity varies all along a linear demand curve. And it varies from being perfectly inelastic near the quantity axis here, perfectly inelastic. So something like, is your elasticity equal to 0? In other words, when the price changes, the quantity doesn't change at all. Okay? So maybe something like insulin. People need a certain amount, so if the price rises to whatever quantity demand, it doesn't change or fall. At the midpoint of your demand curve, you find your elasticity is equal to 1. We know, as I said, there's always a negative sign always in front of your elasticity, or negative 1. And at this axis here, vertical intercept, we find your elasticity is perfectly elastic, incredibly sensitive to the price. So it's these infinite, ignoring the negative, it's an infinitely large elasticity, huge response as the price changes. So it lies between 0 and 1, ignoring the negative just as we classify it for now, taking the absolute value. It lies between 0 and 1. We call that an inelastic demand, when it lies between 0 and 1, more technically minus 1. So values like 0.2, 0.5, 0.8, those would be all price inelastic demands, and they'd lie in this section. And between this point, where it ranges between 1 and infinity, you get an elastic demand. Okay, something like greater than 1, like 1.5, 3, 5. Okay, so when you classify, just ignore the negative as you do so. If it lies between 0 and 1, it's in a price inelastic. 1, it's unitary price elastic. And if it's greater than 1, anything greater than 1, it's price elastic. But can you see why a monopolist will never operate in the inelastic portion of its demand curve? Well, typically a marginal cost curve is going to be upward sloping, okay? And it's going to profit maximize where its MR, this purple line, intersects the MC. Okay, so your MR, the purple line, intersects the red MC curve. And you can see that that's typically going to be on the left-hand side here of this diagram. It's not going to be possible for it to profit maximize in this inelastic portion. Why? Because your MR curve, if you continue it here, you can see it's negative. It's a negative territory. It's not going to operate where you've got negative marginal revenue. Okay, so it's not going to operate in this section of the demand curve where your MR becomes negative. It's not possible for it to also intersect with a upward sloping MC curve. So it's going to be operating somewhere to the left of this, the midpoint, where the elasticity is equal to minus 1, somewhere along this section, somewhere in the elastic portion. Okay. So let's just have a look at a diagram so that if you get an MCQ, you can tackle this and you can see where the monopolist would operate, and then you can therefore compare it with the other market forms, like perfect competition. Okay, you've got a downward sloping demand curve, you've got an MR curve with the same vertical intercept, we saw twice the slope, okay, cuts the horizontal axis at half the quantity. If this is 24, this will be 12. And we start off, as I said, when you look at the diagram, you're going to get confused, and I say, remember what I call an amnesia rule. It's certainly not called that in economics, but we start off with profit maximization, which is MR equals MC. Your purple line equals your red. Okay, they intersect there. And that gives you your profit maximizing output of 6 units. And at that output, you can compare the various things. You first of all, at that output where MR equals MC, you find your output and you go up to the demand curve to first determine the price the monopolist charges. It's $18. Okay. And the first conclusion you can draw is that the price of $18 is greater than your marginal revenue and your marginal cost, which intersect there. So your price is greater than your marginal cost, given by the red line, of 12. So a monopolist charges a price greater than marginal cost. It's allocatively inefficient, unlike perfect competition where price was equal to marginal cost because the demand curve was horizontal. Okay. Furthermore, I gave you those 3 rules that in the first session that are vital to remember. Profit maximization, MR equals MC. Number 2, compare average revenue, or the price of 18, with average total cost. There, that's AC, or average total cost, given by this curve at this point, to see if it makes a profit or a loss. And you can see, reading off here, that its average total cost is 8. So the price, or average revenue, is 18. The average total cost is 8. So it's actually making a profit of 18 minus 8. It's making a profit of $10 per unit. And you can actually multiply that by the number of units, times by 6. It's making a profit of 10 per unit times 6. It's making a profit of 60. There it is. You can shade it in. Difference between price or average revenue and average total cost times by the number of units gives you your profit in that box. And you therefore know it's going to stay open definitely because the price of 18 also exceeds your average variable cost at this level of output, if you read across there. Okay, and profits maximized, as you see, where MR is equal to MC, according to your profit curve. All right, some of the definitions from first year are put on the left-hand side, you can just remember. These are just notes to go with that diagram. I've talked you through it, but you see where you start off with MR is equal to MC, see the output, see what the monopolist charges by going up to the demand curve, what the consumers are willing to pay. You read it off, okay? And we found price was above marginal cost. We also found that the price was above the average variable cost, so it stays open. And price was above average total cost, and it made a total profit. We worked that out. So these are just notes to accompany that. The final thing that we want to look at in this section, so we can compare the market forms, is the concept of market power. And that's the ability of a firm to charge a price above marginal cost. And it's given, we measure it. We can measure it in a couple of ways. You can measure it by the Lerner index, it's called, or by your price to marginal cost ratio. So the first way, via this Lerner index, it's literally defined, the Lerner index, or LI, is defined as price marginal minus marginal cost over price. So to think about it is, what is the ability of a firm to mark the price up above marginal cost as a proportion of price? So the more it can raise the price above marginal cost, the more market power it's got. Recall that this value is 0 for a perfectly competitive firm. Let's get the pen so I can remind you of why. Okay, so in perfect competition, we know if you put MR equal to MC for profit maximization, we know that MR is also always equal to price because it faces a horizontal demand curve. So, and if you're asking why, make sure you go through the first session again and those chapters 8 and 9. Okay, so price is equal to, therefore, marginal revenue and marginal cost. So we know that price was equal to marginal cost in perfect competition. There's no markup of price above that. So you're going to get a value of 0 here, okay, because price is exactly equal to marginal cost. So we get a value of 0. So if you ask what's the learner index for a perfectly competitive firm, it will be 0. The learner index becomes greater the more the firm's market power increases. So for monopoly, the value will tend towards 1. Okay, it'll be closer to 1. So a learner index varies from 0 to 1. 0 for perfect competition to 1 as it becomes more monopolistic. Okay, and as the demand curve becomes less elastic or more inelastic, if you like. So think cigarettes, etc. The more inelastic your demand for your product, the less sensitive are consumers to a change in its price, the greater is your ability to mark the price up above marginal cost because you've got more market power, and this literally measures it. And we found that this learner index is also related to elasticity. It's equal to -1 over your price elasticity, so it's inversely related to the elasticity. And the lower is your elasticity, the higher, therefore, will be your ability to mark up price above marginal cost. So remember from that example, if you've got a value, if your price elasticity is the percentage change in the quantity demanded over the percentage change in price, say you raise your price by 1%, okay, so you raise this, you know, that's going to fall or vice versa. We're not really interested, as I say, in the direction of the change, but the relative amount of the change is what we're interested in. Say you raise your price by 1%, but the quantity only falls off by 0.5%. We find that it's therefore worth raising the price, okay, because the change in price is bigger than the change in quantity. And to understand elasticity, you know, some students think it's a boring concept, and when I teach it in first year, I always say to students, it's actually one of the most important things, price elasticity. Imagine if you have a company or you're in charge of marketing of a product at Unilever or something. What do you do to the price? Do you raise it? Do you lower it? How the heck do you know what to do about it, to do with it, if you've never learned about elasticity? And to understand what elasticity really is measuring, it's looking at how it affects a change in, say, price will affect your revenue. So we know that, say, if you raise price, quantity falls. But we're wanting to know which effect dominates. If it's an inelastic demand, the effect that's going to dominate is the price effect. Here, as we saw here, the price effect is greater than the change in your quantity demanded. This effect dominates. So if you're putting the price up, that's going to dominate. It's bigger than any fall off in quantity that's going to occur, so you should do that. So cigarettes, etc., raise the price in order to increase your revenue. That's the dominant effect. And it's just the opposite if there's an inelastic demand. There you should rather lower your price because the quantity therefore will rise and the quantity effect will dominate. Okay. So if you look at this table, we find that the greater your elasticity, ignore the negative, okay, price elasticity, the more infinite it is, okay, that a firm, the greater the price elasticity an individual firm faces, the lower is the learner index. So think of perfect competition, where you've got a perfectly elastic demand curve. It's got a learner index equal to 0. And your learner index rises towards 1 as your market power increases, the firm's got greater market power, and your elasticity of demand is actually much lower. Here it's only like 1 as opposed to infinity here. All right. So the lower the elasticity, the greater the learner index, given your formula, and the greater the ability to mark the price up over marginal cost. You can also measure market power in terms of a ratio of price to marginal cost. And sometimes past papers have asked the question, what's the price to marginal cost ratio for perfect competition? And the answer is not 0. It's not like the learner index. The ratio that ratio will be 1 for perfect competition. Why? Because the price is, remember, in profit maximizing equilibrium, MR is equal to MC, and we know for perfect competition that MR is also equal to price. So price equals to marginal cost. So these two are exactly the same. So say the price is 5 and the marginal cost is 5, you get a ratio of 1. So for perfect competition, you can see your ratio is 1. And this index will rise, or ratio will rise, as you head towards a monopoly. But your price is much higher in relation to your marginal cost. Okay, so you're tending towards perfect competition this way as you move down, and towards a monopoly as you move up. Last thing, just to remind you of what we mean by consumer surplus. Whenever you're going to shop, and say for example you want to buy some new clothes, say you're going to H&M, this example takes, and you trying on a new pair of jeans without checking the price. In your mind, you've got some kind of reservation price. What's the maximum you're actually willing to pay for those jeans? All right. So we call that your reservation price. So, for example, it might be 500 Rand. It's the tops they're going to get out of you. All right. So you check the price tag, and they're 450. Great. Yes, you're going to buy them. And you have therefore made what we call a consumer surplus on them. It's simply the reservation price that you had in your mind, the top amount you're willing to pay, minus what you actually do pay, the 500 minus 450, and you've got a bit of a consumer surplus of $50 on those jeans. So we use these concepts to therefore define welfare and to compare the different outcomes of the various markets. Welfare is the sum of all the consumer surplus to consumers in society and all the producer surplus. Recalling that consumer surplus is therefore the difference between what a consumer is willing to pay. Remember, say for a first unit of a good, there's somebody there that's, say, willing to pay 8 Rand for that unit. And let's say, though, that the market price is only 6 Rand. They have therefore gained a surplus on that unit of 2. Okay, that's their consumer surplus. Say on the second unit, somebody was willing to pay 7 Rand, okay, for the second unit. So this was your consumer surplus on your first unit. For the second unit, somebody's willing to pay 7, but you only end up paying 6. They have a surplus of 1 Rand on that unit. So you'd add up across all units for a continuous demand curve. You'd add up all your consumer surplus, and you get a triangle. You wouldn't get these discrete units. But that's the basic point. It's the difference between what consumers are willing to pay on a unit and what they actually pay. So it'll be the area below the market demand curve and above the horizontal line at the market price up to the quantity they purchase. We'll see that just now. Likewise, the difference between the price a producer gets for a good and what it costs to produce them gives you your producer surplus. So it's the area above your marginal cost curve and below the horizontal line at the market price, up to the quantity produced. Let's see what we mean. Okay, so for perfect competition, we find welfare is actually maximized. Your equilibrium is where your market demand, the green line, intersects the supply, the red line. Okay, there's your equilibrium price and your quantity for perfect competition, right? So your consumer surplus is this whole green shaded area. The difference between, say, like on a first unit, somebody was willing to pay that, and they only end up, for the first unit, but they only end up paying this amount here, because this is the market price. So it's 5 Rand, and say they were willing to pay 10, you've got a surplus there of 5 Rand on that unit. This area above this market price and below the demand curve, below this demand curve. Area below that and above this price line, this entire shaded area will form consumer surplus. All right. the area below this price line, okay, this horizontal line, and above your marginal cost curve, this is your producer surplus. The difference now between what the producer gets, say for first unit's 5 Rand, and say it costs them maybe 2 Rand to produce that unit, you can work out the surplus on that unit and across all units, and you get this red area. Okay. So in the other diagram here, where we're going to compare a monopoly and perfect competition, we find that a perfect competition, or the perfectly competitive market, will produce where the marginal cost or supply curve for the whole industry, okay, is equal to your demand curve, the blue line, over here. Okay, that's your perfectly competitive output. And you find you get a price of 16 and an output of 8, where your market demand equals market supply. If you're wanting to compare perfect competition with a monopoly, you've got to compare like with like. You can't compare one individual perfect competitive firm with a monopoly, because the one firm's not serving the whole market. You've got to compare the whole industry, all the perfectly competitive firms together, and say they face exactly the same demand conditions, the same demand as a monopoly. You can then compare them. All right, so that's where perfect competition would operate. A monopoly is one firm, and so when you've got one firm, you go by the profit maximizing rule. We're not doing that for the perfect competition because you're taking the whole industry. So one firm produces where MR is equal to MC. There's MR, there's MC. We see that's going to occur here. Okay, that's where the monopolist produces. MR equals MC. Output is 6. Go up to the demand curve at that level of output, and you can see that your price is going to be 18. Okay, and you can then foresee that your consumer surplus associated with the monopolist is area A, the area below, let's get the laser pointer, the area below the demand curve and above the price line up until what's produced in monopoly, which is 6 units. So up until that point, it's the area between the price that's charged and what people were willing to pay, given by the various points along the demand curve or willingness to pay curve. Okay, so it's area A. What will produce the surplus be? It'll be the area below the price line, up until the quantity produced, and above the marginal cost curve. It's this green area. So it's area B, if you like, that little rectangle, and D, this whole area here. Okay, or you could work it out as this rectangle here plus this triangle. There's a deadweight loss with the monopolist because it produces less than under perfect competition. Perfectly competitive industry would have produced 8. There's less produced. So, and why we call it a deadweight loss is because of this lost output. And because a monopolist refuses to charge less than 18, there's some consumers who would have been prepared to pay slightly less, like $17 or $16.50, etc. And because the monopolist doesn't bring them into the market by charging a lower price, this output's lost, and it's gained by no one. So an area, a deadweight loss, is area of production lost output gained by no one, and it's equal to C, this little triangle, plus E, that little triangle there. You can work it out. Okay. Perfect competition, you could work out your consumer surplus would be area A, B, and C. It would be this whole triangle here. The area below the demand curve and above your price line up until what's produced, up until here. So it's this big triangle. It's area A, this little rectangle here, B, and little c. The area, the difference between what people were willing to pay as given by the demand curve and what they actually pay across all units. So areas A, B, and C, as opposed to producer surplus, which would be the area below the price line and above your marginal cost curve up to what's produced here, it would be areas D and E, would be your consumer, your producer surplus. And therefore you can see that a monopolist is definitely less efficient because it charges a price above marginal cost, as we said. It's allocatively inefficient. But furthermore, there's a deadweight loss, less output produced, higher price charged, etc. So consumers are definitely going to prefer perfect competition, okay, which maximizes welfare, no deadweight loss, as opposed to a monopoly, which is inefficient, too few units are produced, which results in a deadweight loss. So these are notes to accompany what I've explained in this diagram. And hopefully, as I say, this comes back to you from first year. Go through that, and we now have finished recapping the key concepts that we need going forward. And we've also introduced two new things that you haven't seen before, and that's the definition of market power and how the different measures of that, the learner index and your price to marginal cost ratio, so that you can look at an industry and make certain judgments about the amount of market power based on those measures.